The focus of this video is on linear graphs, with an emphasis on how to find the slope, the y-intercept, and an unknown component of a coordinate using two known coordinates. We'll start here with some graph paper. We see the x-axis is horizontal and the y-axis is vertical. I've also provided the location of two dots that we're going to plot on this graph. Their coordinates are at 2 and 5 and 4 and 6. That means we're going to go over 2 on the x-axis and up 5 on the y-axis to locate the first dot. The second dot is at 4, 6, so we're going to go over 4 on the x-axis and up 6 on the y-axis to plot our dot. When we have two dots, we can connect them and even extend the line past them to get a sense of what the full graph would look like if we had more dots following the exact same trend, or that were part of the same linear graph. We can see there's a pretty clear positive trend happening just from these two dots. The formula for a linear equation or a straight line graph is y equals bx plus a. This might look really familiar to you because a similar formula is used in mathematics. In math, we typically say y equals mx plus b, but the two formulas actually mean the same thing. In the stats formula, b stands for the slope and a stands for the y-intercept. In the math formula, m stands for slope and b stands for the y-intercept. We'll use the stats version, where b will stand for the slope and a will stand for the y-intercept. Let's start by understanding the slope. Slope is sometimes called the rise over run. This means how far did we move up the y-axis divided by how far we moved along the x-axis. So we can actually solve this by using two coordinates. If I take the location of a second y, in this case that would be 6, and subtract the location of the first y, in this case it would be a 5, I get the change in y, or the rise in the graph. If I divide that by the second location of x, which in this case is a 4, and which has had the first x, x1, subtracted from it, which in this case is a 2, we'll get the slope. If I look at my graph, I see that for y, I started at a 5 and ended at a 6. So my movement is 6 minus 5. That's the ending location minus the starting location to give me a movement on the y-axis equal to 1. If I'm looking at my x-axis, I moved 2 units. I had a starting location of 2 and I ended at a location of 4. So I moved over 2 units. So my slope is 1/2. That means for every 2 units I move along the x-axis, I increase on the y-axis 1 unit. I have a positive slope here because my graph is angling upward. So my rise over run here is a movement of 1 divided by a movement or 2. It's also fine to represent this using quotient format, which would be 0.5. I'm going to stick with the fraction version for a moment because it makes our interpretation on the graph a little easier to see. According to my slope, every time I move 2 units on x, I'm going to go up 1 unit on y. I can follow my line and see that this continues to be true. If I go over 2, I go up 1. I could also say the same thing as going up 1 is equal to going 2 over. That's a gain in 1 over y is equal to a 2-unit gain in x. And you'll see this also holds true as we move further along the graph. Statisticians like to interpret the slope because we use it to find out things about the relationship of x and y. If the slope is 1 over 2, we might say that for every 2-unit increase on x, there is a 1-unit increase on y. Now that we know what the slope is, we're ready to find the y-intercept. The y-intercept is what y equals when x equals 0. Another way of saying this is that the y-intercept is where the line crosses the y-axis. If I'm looking at my graph, I can see pretty clearly that the line is crossing the y-axis around unit 4. So there's a coordinate on this graph that's at 0, 4, or 0 on the x-axis and 4 on the y-axis. But if we couldn't see it visually, we could solve this using the y equals bx plus a formula and the slope that we've already found. To do this, we just need to plug in the things we already know. Well, we know that the slope is 1 over 2. We can choose either of the coordinate pairs we already know and put them in the equation so that we can solve for a. I'm going to use 6 and 4 as my coordinate pairs. I'm going to plug the 6 in place of the y and 4 in place of the x. Now I'm just going to use what I know about order of operations and solving for unknowns to find a. I'm going to try to isolate a. I know that 1/2 of 4 is 2, so I can simplify there. Now I have 6 equals 2 plus a, but I want to get a alone. So I'm going to subtract 2 from both sides. Now I get 4 equals a. So my y-intercept is 4. Recall that I said earlier that the y-intercept tells us what y equals when x is 0. And if we look back at our graph, we see that we had a coordinate that we thought visually was the location of the y-intercept that was at 0 on the x-axis and 4 on the y-axis. And we just got confirmation because we found the y-intercept was 4, that the location of y when we crossed the line was at y equals 4. Now that we found b and a, we can fill in the linear equation for this specific graph. So we get y equals 1/2 times x plus 4. This is really useful if we know half of a coordinate and we're trying to find the other part of the pair. Let's say I want to know what y would equal if x was 8. In order to find that, I can use this equation and fill in the x and then simply solve for y. So I get y equals 1/2 times 8 plus 4. That means y equals 4 plus 4, because 1/2 of 8 is 4. So y in this case would be equal to 8. This means I have a coordinate on this graph where the line crosses 8, 8. Let's double check it visually with our graph. We'll go over 8 on the x-axis and up 8 on our y-axis. And we see that we have hit where the line is crossing. So there is a dot at 8, 8. The formula was helpful in finding this unknown component of the coordinate pair. We can do this for any other dot on the line. Let's try another. Let's say we want to know what y will be when x is 0. We already know the answer to this because we saw on our graph earlier that we had a dot at 0, 4. But let's use the equation to confirm. Here I get y equals the slope times x, which is 0 in this case, plus the y-intercept. When we solve, we get y equals 1/2 of 0 is 0 plus 4. So that means our location is at x equals 0, y equals 4. Now let's see if you can try to find one of the unknowns in a coordinate pair. Pause here and find what y would equal if x was 5. You should find that when x is 5, y is equal to 6.5. And if I follow this and go over 5 on x and up 6.5 on y, I see that I am intersecting with our graph at that location 5, 6.5. Now let's try one that's slightly more difficult. Pause here and find x using our linear equation when y equals 7. This time we get 7 equals 1/2 times x plus 4, and we need to isolate that x to solve for it. So here we have a dot located at 6, 7, over 6 and up 7, and once again we've hit that dot directly on the line. Now it's your turn to try all the pieces together. Pause here and solve for the slope, then the y-intercept, then use the linear equation with that slope and intercept to find the unknowns in the table below. There we have a coordinate of 0 with an unknown y, 5 with an unknown y, an unknown x with a y of 4, and an unknown x with a y of 10. We should get a rise over run of 2 over 1, which is equal to 2. So our slope you can write as 2 over 1 or simply as 2. If we solve for the y-intercept, we should get a equals -1, and we can see that if we continue to draw the graph, we'd be crossing at that -1. Now your y-intercept can be a negative number or a positive number. It can be 0. It really depends on the specific graph. When we put the pieces together, our equation is y equals 2x plus a negative 1, or we can simplify this by saying y equals 2x minus 1. I'm going to use the simpler version, y equals 2x minus 1. When I plug in my first known, which is an x equal to 0, I get y equals negative 1. When I plug in x equals 5, I get that y would equal 9. When y equals 4, and I plug this in, I get that x equals 2.5. And when y equals 10, we get x equals 5.5. And I can plot all 4 of these dots on my axis, or on my graph. So now I have 6 locations, our first 2 at 1, 1 and 2, 3, and our 4 newly found dots. Notice here that they're all falling in line. They're all still hitting that same trajectory of that original line drawn with the first 2 dots. That's because they're all coming from the same line on the same graph and thus have the same equation.